Hi guys, BuildZoid here, and today we're going to be taking a look at the Zotac 2080 Ti Amp Extreme. So these two PCB pictures are from Guru 3D's review of the 2080 Ti Amp Extreme. So thank you for the pictures. I kind of wish you guys had, more pixels, and if the pixels were better, that would be good too. Like seriously, the focus in this area is a disaster, and then this rear shot, it's just like that's like the only part that's like in focus. Well, I guess this area in general is, but yeah. So anyway, so we've got these two pictures from Guru 3D, which there's just not any better pictures of this PCB that I've been able to find. And in the background, I've got a reference 2080 Ti PCB because we're going to be doing some comparisons to that, and that is from Tech Power Up from their review of the 2080 Ti. So thank you to them for providing the good quality pixels. So anyway, yeah, let's take a look at this. I really hope I don't get complaints for complaining about the number of pixels in these pictures, but it's just like, look, if you're gonna take photos, like, try to take them so you can actually see what's in the picture. Anyway, so 2080 Ti Amp Extreme. So this is Zotac's flagship card. We're not really going to talk too much about the actual power delivery system because it's the standard issue high-end 2080 Ti power delivery system, which we've seen all 1,000 times before, where this is the V-core. The layout's a bit unique, so that's the part I'm actually interested in talking about, but the actual componentry, I mean, literally most 2080 Ti's are the same thing. The controller is, of course, another UP9512, which is the standard issue controller for a 2080 Ti V-Core, which runs in 8-phase mode. Then, of course, you might be like, so how do you get all these inductors? Like, this looks a hell of a lot like a 16-phase. Well, it's very simple. You just put your two power stages together in a... You take your two power stages and you take your one PWM signal and you feed that from the controller into two power stages, and bam, you've now got two 70 amp smart power stages. Now these I think are from actual like on semiconductor branded parts, which I would assume just means that they have the same type of there's still a 70 amp smart power stage. They're made by the same like Fairchild is technically owned by On Semiconductor, so I'd say these are probably fairly comparable to the FDMF 3170, which is basically comparable to every other 70 amp smart power stage you've ever seen on a 2080 Ti. So this is the standard, 16 70 amp smart power stage 2080 Ti VRM. Nothing really special here, other than the fact that these are actually On Semiconductor branded, which is a bit rare, because normally they'd be Fairchild. But OnSemi owns Fairchild, so I don't honestly think there's much of a difference there. So in terms of the actual power delivery, you've got like 104, like two 70 amp smart power stages in one phase. So you've got a monster, on paper 140 amp phase, but it doesn't really work like that because you need to consider the power efficiency of the power stage. And like a 70 amp smart power stage hits peak power efficiency, I think around 25 amps. So you don't actually go like this is not a 70 amps times 16 VRM, okay? Which would I think be 1,080 amps. Like it would just produce so much heat at that point that like technically yes, each power stage can under certain operating conditions handle 70 amps. If you try to run 70 amps through all 16 of them at the same time, it's going to produce so much heat that you'll need like a water block to take care, like to cool the VRM. It's just like that's not really practical. Also, it helps that 2080 Ti's don't pull 1,000 amps. So, yeah. Anyway, so we've kind of got the standard, monster 8-phase V-Core VRM that you've just seen on literally every 2080 Ti ever made. But what's kind of special about this card is the layout, which I pointed out earlier in that Zotac, basically, like, I don't get why they did this, or actually, no, I can kind of see why they did this, but it's still not very. I'm not a fan of the decision. So basically, if we look at the reference NVIDIA card, we have part like vCore VRM over here. So this all here is vCore, and that's basically, I think that's like 3 phases worth of vCore. It might actually be 6 phases depending on just how NVIDIA is splitting the PWM signals between their power stages. Like it doesn't really matter. As in like they could have a PWM signal running like that. right? Where it goes to sort of 2 power stages at the same time across the board, but they could also be doing something like that. Yeah, and the VCore controller on this card is on the actual back of the card, so that's why I'm not drawing out to the controller, because that's memory power up there. But anyway, so if you look at a reference NVIDIA 2080 Ti and most other 2080 Ti's, if not all other 2080 Ti's, because the Zotac one is the first one I've seen that uses the layout that Zotac has gone for, what you'll notice is basically you have VCore over here, and then you have all of this VCore over here. Wait a minute. VCore over here. There, because the reference card has 3-phase memory power. But basically you have these 2 big groups of VCore VRM phases. And the cool, basically, advantage with this is you are now pushing current to the core from 2 sides. And this basically means that, well, you can reduce the power plane power losses because your phases are closer to the actual silicon that they're trying to power. And I would assume that because NVIDIA actually, like, the reason why you don't see this style of, like, VRM on either sides of the chip layout on older cards is because you actually need to adjust or at least to get optimal results out of this style of, VRM layout, you'd basically have to have a BGA that's actually designed to have power coming in from both sides. Because if you look at a lot of ball grid arrays for, like, say, older NVIDIA GPUs, you'd basically have most of the VCore power delivery coming into the chips or coming into the substrate in this area, and then you'd have this sort of like section down here because they'd have memory over here, and then they'd have their PCIe interface down here. So you'd basically have only one place where, like, your VCore VRM would be here, and then your current would come into the core like that. And maybe through some inner layers of the PCB, it would also get, straight across. But you definitely have a power plane that would go sort of like this, and you'd have the BGA set up to take in power from that area as well. Now, on a 2080 Ti, I would assume that you have power hookups basically going something like this. Because that kind of makes sense with the way you have all of your memory laid out, and then your PCIe interface could squeeze into this area over here, right? Because, like, that's the thing, is, like, you do need to fit the PCIe somewhere. So then your power delivery can sort of come up through this area into the chip. And the benefit of doing this is obviously you're going to have more even sort of voltage distribution across the actual package. Because if you look at some of the really high current draw GPUs, if you measure the VCore power, say, here, and then you measure the VCore voltage over here, there's actually a difference in voltage between those 2 points. And that's especially, like, the more current a GPU pulls, the more of a difference you're going to see even across very small distances on the power plane. And so, I'd assume that NVIDIA basically did this style of layout because when they were designing their reference card, it was like, okay, we could do the, usual thing that every board partner for the last several years has been doing and just put 2 rows of VCore VRM like this. And then you basically just have slightly higher power losses through the power plane, and you'd have your lowest voltage zone on the GPU core would be somewhere around here. But NVIDIA, basically, for the reference card, they decided, yeah, we're just going to try we're going to feed power to the chip from both sides. And this can basically have some pretty, major, this can have some positive benefits for power delivery. And then you look at Zotac's design, and it's just like, all that work, so basically, I'm assuming that NVIDIA actually, designed this substrate to support that power delivery from both sides design style for the reference PCB. Because they can do that, they're the ones who designed the substrate. If you're a board partner, if the substrate is laid out with all of the power connections on this side, it doesn't make sense to try squeeze a VRM over there, right? It just doesn't make sense to try do that. But then you have Zotac, where it's just like, yeah, you know how NVIDIA, probably power, I'm saying probably because I've not actually seen the assignment of the various balls on the substrate of the TU102 chip, but so I'm not 100% certain that this is actually true, but I would assume that, if NVIDIA is putting VRM on either side, they probably have a power configuration that looks something like that. So Zotac then goes yeah, so all of that optimization that NVIDIA has done to the BGA, yeah, just ignore that. We're just going to cram all of the current into the chip from one side, which basically means, yeah, you're going to have a low voltage zone, and sort of like the lowest voltage being applied across the chip is going to be in this area, as you're just going to have power loss going across the power plane all the way to basically here. And that can potentially lead to worse overclocking in terms of just core power delivery, because ideally you'd have the same voltage applied uniformly across the entire chip, right? Like, that's best case scenario. You have the same voltage everywhere. You don't have a slightly lower voltage in one of the corners of the chip because it's slightly too far away. So that's kind of the thing where, yeah, I'm not really a fan of the way Zotac has decided to lay out their vCore VRM, because it's just like, this is not optimal. Especially if NVIDIA did actually optimize the substrate for power delivery from both sides, which I assume they did, because they have the power to do that, whereas board partners don't. It's like, if the substrate is not designed for it, you're probably better off not trying to do it. So other than that, so yeah, like, this layout basically probably not ideal for core overclocking. Okay, at the same time, how much of a difference would I expect this to make? Probably in the tens of megahertz. So, like, if you tested, I don't know, a couple thousand of the amp extremes, I'd expect them to have maybe 10 megahertz, 20 megahertz on average lower core speeds than 1,000 of some other partner card that goes for a better power plane design than this. Because this just, like, yeah, I don't think this is the optimal way of powering a 2080 Ti, considering literally everybody else takes advantage of the reference 2080 Ti design that NVIDIA went for, and then they just kind of add more power stages to it. They don't add more phases most of the time, because A-phase controllers are, well, like, I've not seen a 2080 Ti using the XDP 132G5C yet, so that's kind of that. So you basically get 8 or 10 phase 2080 Ti's, and they put the VRM on either side of the core. And then there's Zotac, where it's just like, we still have the same 8 phase everybody else does, but our power plane is just designed like this was a 2080, which yeah, I'm not really a fan of that. I really think, like, the core power delivery here is a bit suboptimal because of that. Another interesting thing is, like, Zotac is using absolutely gigantic capacitors. So these are all 1200 microfarads, which I have to question, like, how effective that is. So there's a lot of capacitance here, but these are through-hole capacitors, and basically per microfarad, these are less effective than your SMD capacitors, is the best way to sort of put it. Like, obviously, like, basically what I mean by that is, if you have, like, a 47, say a 560 microfarad capacitor in this package style, that is potentially going to make, depending on what exactly the transient behavior of your chip is, that type of capacitor is going to do a much better job of filtering the switching noise and the transients, even though it might have an overall lower capacitance. So, and this is probably the highest capacitance I've seen in total on a 2080 Ti. So I'm really like that. Like, this just seems like, I'm not sure this actually makes sense to use, but at the same time, there's a good chance that Zotac just has piles and piles of these lying around, so, that they just used them. But I would have honestly preferred if they had maybe, like, these capacitors over here, I'd say are probably completely unnecessary, as they don't actually do anything, because not only are they giant through-hole polymers, which is, like, it's fine, big through-hole polymers can work in certain scenarios, but they're even further away from the core than, like, they're really far away from the actual core. So these probably don't do anything at all, and they're unnecessary. And quite frankly, I would have preferred if, they would have, like, taken these out, and then used, like, tantalums on, like, they have all this empty space on the vCore power plane right here. They could have thrown some tantalums on there. So yeah, the vCore power delivery here is kind of just, like, it's very powerful, because we've still got 16, 70 amps more power stages, but in terms of the actual power plane and capacitor configuration, I'm not a fan. Though admittedly, on the back we have this fancy capacitor cover, and I really wonder what's actually hiding under it. We could have a pro-adlyzer, which is basically a really fancy type of SMD capacitor that they're great, except for the part where you literally can't buy them in a SKU rated for more than 1,000 hours, so it's a very low endurance type of capacitor. But on paper, the idea with the Pro Analyzer was that you could replace all of your multi-layer ceramics and well, all of this basically behind the core, you could replace that with one single capacitor. The only issue with them is the endurance is terrible. But the thing is, they don't come in like this casing is not a standard package for a Pro Analyzer. So I have a sneaking suspicion that there's probably just like regular tantalums or maybe a pile of multi-layer ceramics hiding under this cover, which is just like I would have honestly preferred if we could just see the capacitors that are actually there. Like this right here, this is marketing wank. Um, you know, so I would have preferred being able to see the actual capacitors, and yeah, not really a fan of the like. Yeah, not really a fan of the cover here because it's just hiding whatever actual capacitors they're using. And, you know, they could be actually using some really nice SMD polymers, but can't see them because there's a stupid marketing wank on top of it. So, yeah, not really, just in general, I'm not a fan of the power delivery for the core on this card. It's just like they're not using the power plane layout that I'd assume NVIDIA optimized for. The capacitor selection is kind of like it's not terrible, okay? Like there's nothing I'm just kind of salty that, you know, it's like I'd rather have these. Like I'd rather have these than the caps that Zotac actually went for. But ultimately, this can still work fine. And they do have a bunch of multi-layer ceramics jammed in between all of those. So, you know, those could potentially be enough to make up for the fact that your, you know, giant aluminum through-hole polymer, like giant through-hole aluminum polymers have much higher ESLs and much higher ESRs than, well, ESR actually you can get the same. Like you can get a 5 milliohm ESR in a 1200 microfarad aluminum polymer just fine. That's not an issue. But what is an issue is you can't get as low an ESL as you can in a multi-layer ceramic or an SMD aluminum polymer. And that's where, you know, the style of capacitor, like these capacitors that NVIDIA is using on their reference card, they're superior for high frequency switching noise to this style of capacitor. So it's just like, yeah, like this can work. It's just that these are definitely better. So, you know, I would have preferred to see those instead of these, but yeah. Now, in the memory power delivery department, however, which like Zotac basically seemingly just sacrificed the whole optimal power plane layout to the memory power delivery, so you better hope that this actually works. This is the most substantial memory power delivery system you can get on a 2080 Ti. So all of this over here is VMEM. And so that powers all of your GDDR6 memory chips. And normally this would be a 3-phase VRM for your standard 2080 Ti's, but Zotac's gone all the way for a 4-phase, and it is a real 4-phase as they are just using another UP9512 for that. Which does also mean this would be very easy to volt mod, but that's true of most 2080 Ti's because this is a standard chip for all 2080 Ti's to use, and yeah, this chip's very easy to work with. But yeah, so you've got 4-phase memory power capacitors that I'm actually a fan of. So these are tantalum polymer capacitors. They look like they're probably 330 microfarads, and there looks to be about as many, well, more than what NVIDIA uses on the reference design. So I'm a big fan of these. This is a nice memory power delivery system. Then we also have some extra multi-layer ceramics over here on the memory power plane and over here. I kind of feel like these chips down here are a bit neglected, because they are by far the furthest away. Well, okay, no, actually, well, these two chips over here are the furthest away from the actual memory power, like from the actual memory VRM. So these will probably, well, depends how the power planes are designed. I'd assume they probably have a layer where they just have power going this way. Obviously, you have the PCIe interface, but I think that's almost entirely just like that fits probably on one PCB layer on its own. So then you have all the layers under that for other things. Like also the minor rails over here, which would be things like 1.8 volts, and PEX rail, which would be 0.95 volts, or yeah, it should be 0.95 volts. Either way, yeah, so the memory power delivery system, on the other hand, I'm a fan of it. Like, I think I would expect this card to, on average, be a little bit better at memory overclocking than most other 2080 Ti's because, one, we've got, you know, a whole extra phase, so potentially uh, slightly better, well, definitely well, the thing is the memory VRM in terms of power delivery, this is actually excessive. The GDDR6, like, doesn't pull anywhere near as much power as the core does. So honestly, going above the three-phase reference design, I think, is generally unnecessary, but the capacitor configuration is nice. So yeah, like I'd assume this actually might have some advantages in terms of memory overclocking. In terms of core overclocking, I would not expect any advantage from the VRM that Zotac has gone for, because yeah, they've just kind of like, it's big, yes, but it's not very refined if you want to use that terminology for that. Um, so yeah, not really a big fan of like not a fan of the V core. The memory VRM actually looks like it might help in terms of memory overclocking. It's kind of neat that they actually have like a lot of cards. This unpopulated memory chip won't include the capacitors for that memory chip, but Zotac actually does. Like you can't tell that there's a memory chip missing from the capacitor configuration on the back of the card, so that can potentially also help with power delivery to the memory chips. So, and in my experience, like 2080 Ti's do actually benefit in terms of memory overclocking from just having extra capacitors for the memory power. So yeah, I'd expect the memory overclocking on this to be slightly better than reference. I'm not sure if it would be better than other like high-end cards because that's really hard to tell. But definitely, like, I wouldn't expect this to be the worst memory overclocker. And in terms of the core, I wouldn't expect it to win I wouldn't expect it to win anything in terms of the core overclocking, though, just because of what Zotac has done with the capacitor configuration and the power plane. It's very similar to what MSI did with the 2080 Ti Lightning, except on the Lightning, MSI at least kept the power plane layout of the reference design, and Zotac didn't even bother to keep that. So yeah, not a fan of that decision. Now, other interesting things about the card. Well, in terms of shunt resistors, we're looking at a 5 milliohm shunt here, 5 milliohm shunt there. So that's your two 8 pins. Then we have the PCIe slot shunt resistor down here. So that's the one that's used for monitoring how much power comes in through here. Then we also have these minor shunt resistors for the current balancing circuitry because NVIDIA just likes having unnecessarily complicated power delivery schemes even on the 12-volt side of things. You know, it's not hard enough to power the core on the low voltage end. No, you need to make the 12-volt side unnecessarily difficult as well. And then we also have one more of those current shunts on the back of the card over there. So, these little ones over here, like these little ones that I just circled, those are the main reason I couldn't get a 28 when I first tried to power mod a 2080 Ti. Why I was failing at it so badly is these guys. Because if you don't deal with those, like those are still used for current balancing, and the card can still figure out that, wait a minute, there's something not quite right with the power measurements if you don't also take care of these guys. So that's really, really annoying. And basically, these are just used for figuring out how to distribute the power draw between the two 8 pins and the PCIe slot. Now, the reason why I think this is completely unnecessary is each of these 8 pins can easily handle upwards of, what is it, 8.5 amps per pin pair. You've got 3, so I'm lazy, so like 24 amps times 12. That's what? It's 240 plus. So you've got 264 amps at least per 8 pin. And if you have the high current variant of the connector, which this is the high current variant, because you can actually see that these are solid metal pins instead of like, there's a folded metal pin, and that's the 8 amp variant. But this solid metal pin, that's 13 amps per pin pair. So you're basically looking at 13 amps times 3 times 12, which is, I can't do that in my head. It's in excess of 400 watts, if I'm not mistaken. All right, because that's like, yeah. So, you know, like the whole thing about current balancing a 2080 Ti is just like you could just shove all of the core, like you could literally just have all of the power pulled through the 8 pins and it wouldn't be an issue. But then you wouldn't be NVIDIA enough, right? Because the reason why NVIDIA has to bother with all of this current balancing circuitry, and if you look at like AMD GPUs, they don't bother with this because AMD is too cheap to implement this kind of ridiculous current monitoring system. But which I'm fully supportive of. I think this is a complete and utter waste of PCB space. It's just like, why do you need this? Um, but yeah, the thing is, NVIDIA basically has power limits that are that are enforced per power connector. So that means if like basically the concern is, let's say you have a 150-watt limit for this connector, 150-watt limit for that connector, and then a 75-watt limit for this connector, which is all within spec. Then the problem is, what if you're pulling 170 watts here and 130 watts there? Like, this would actually cause current throttling, even though you're still between, like, you're below the overall power limit for the whole card, but you're power throttling because you're maxing out one of your 8 pins. So NVIDIA's genius solution to this problem that they actually created by implementing such a ridiculous current monitoring scheme is, yeah, we're going to add a bunch of extra unnecessary circuitry so that you can take, you know, say a single phase off of the vCore VRM, and instead of having it going here, we can now rewire it to over there. And now you can shift your 20 excess watts of power consumption from here to there, and you can maintain current balance and better boost. And it's just like, or, you know, you could just not have all of this current balancing stuff at all, and you wouldn't have to deal with this. Because the funny thing is, like, all of this unnecessary current balancing circuitry has been present on NVIDIA cards for a very long time, and it's not that uncommon for all of these little current balancing MOSFETs to actually blow up. Which is like my favorite part of it is just like, so, and I don't think they actually blow up because they're underrated and they fail. I think it's more like if something else on the card fails, those act as a fuse. But the problem is, whenever a MOSFET goes, there's a good chance it's going to take out several layers of PCB with it, and it's just like, it would be better if it just didn't do that. You know, it's like, minimize the number of failure points. Like, having actual fuses, sure. Having dinky little MOSFETs that have a tendency to explode whenever anything else on the card malfunctions, not that great. But yeah, praise NVIDIA. Anyway, for the actual current monitoring, we have these two chips over here, and those are NCP 45491s, and those take care of all of the current monitoring. So yeah, if you actually wanted to do like a really fancy, well, basically you can look up the data sheet for those, and then you can do a really fancy power limit removal using the data sheet for those. Instead of trying to do something like short the shunts out with the correct amount of resistance. Because the thing is, if you short the shunts out too much on some cards, it'll actually put them into safe mode, and then they won't run properly. So, yeah. Anything else I want to talk about? Not really. Alright, so... yeah, Amp Extreme. Interesting memory power delivery system. Like, I'm actually a fan of the memory power delivery, but the vCore, nope. Just absolutely, no, definitely out of the high-end cards, the vCore power delivery system is just like, I'm not a fan of it. That doesn't mean it actually, in the real world, has major negative consequences. It's just like, on paper, this doesn't seem to be the optimal way of doing things, considering how literally everybody else does it, and even what NVIDIA seemingly designed the card around in terms of their own reference card, in terms of their reference PCB. But yeah, other than that, I mean, it's a 2080 Ti, you know, 1670 amp smart power stages, 8-phase vCore, 4-phase memory. Yeah, and then, of course, the usual ridiculous current balancing system that you get on basically all 2080 Ti's as well, because NVIDIA just can't help themselves. It's like, but it's too easy to just build an 8-phase. We need a power balancing system for it now. So, yeah, that's it for the video. Thank you to Guru 3D for the photos. I do really wish they had more pixels, but, I mean, we can still, like... we can still see enough to go like, okay, I can still see enough of the PCB to go like, oh yeah, I'm not really a fan of the way this is set up. And then thank you to Tech Power Up for the reference 2080 Ti PCB picture. There will be links to their reviews of both of the cards down in the description. And yeah, that's it for the video. So like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. If you'd like to support what I do here with actually hardcore overclocking, I have a Patreon where you can support me directly. There's a link to that down in the description below. And there's also the AHOC Teespring store where you can pick up shirt stickers, post. I get the feeling that if you order anything off of Teespring right now, you're probably not going to get it. So I don't know why I'm shouting that out. So honestly, actually, you know what? Considering current events, ordering a t-shirt is definitely low priority. So just don't actually use the Teespring store. But there is the Patreon, so like Patreon, sure. Teespring, as of right now, I'd say probably yeah, not a priority thing. You should probably not order any merch right now. At least, like, to me, it seems like a really frivolous purchase to be ordering merch right now. Um, so yeah, that's it for the video. Thanks for watching, and goodbye.